of course, we had another exercise, which is about satellite validation. So this one also I included. You can just simply run. If you have problems, we can discuss it later. So this one also includes sample data here. These are the sample data. You can try to submit it. This is the data you submit to online matchup tool. So I will open the online matchup tool. You go to the NAUPAP Marine Environment Watch. So here on data evaluation. So I simply choose, let's say, MODISA and in situ. And then I can type my name and my email. And then I choose a file. Here inside sample data, I can select, I will just select this smaller file. And then it will upload the file. And then here on the data type, I choose the ocean color. And I can either check all variables or I can simply pick chlorophyll. And I want to keep everything default. So here, instead of 50, let's say I want to have 25 for the minimum number of valid pixels among the 5 by 5 pixels. So I want to have 25% valid. And I want to have 3 hours of time difference between my observation and satellite. And please remember, the time here should be UTC time. If you use a different time, you might not get, for your location, you might not get matchup. And then here we have these are on by default. Remember, land is already masked. Cloud ice is already masked by default on level 2. So if you want any additional flag, you can select it by clicking, let's say, high glint, sun glint, or other flags. You can just press on or off. And then once once you press on, it means that the data that has that specific mask, as we saw here, as I showed here, for example, this data, which is by default not masked, if I press on, this data will be masked, meaning all this part will be invalid before the processing of matchup happens. So you decide which flags you want to turn on or off. And then once you have everything decided, you push here, submit. So when you push submit, it says now working, please wait a minute. So yeah, of course it's giving you time here, but you don't have to wait for this. Once this is finished, it will send you an email telling you that the matchup has finished. Currently, because this is still a prototype system, we have an issue that after 108 seconds, the system reports some error and says contact administrator or something like that. So don't worry about that. If it is running like this, it's okay. That is just a timeout of this browser. On the back end, everything is running okay. And all you need to do is wait for the result. And once you receive the result on your email, meaning that the matchup has completed successfully. So this is still running. And if it finished, I will show you an email that I will receive from this system telling me that the matchup is completed. And now I can use the data for my analysis. So for the validation, we had this notebook. It follows the similar structure. Everything is similar on top. And again, what we have to do is import the modules. And I believe at this time, you no longer have problem importing the modules. And then again, import this local module. And here, now, for example, for this exercise, for Modis Aqua, I downloaded this Nomad data. You can, if you click here, the link, you be redirected to this data set. And for SGLI exercise, I'm using that Toyama Bay data set, which is obtained from NPEC, Northwest Pacific Region Environmental Comparison Center. And here now we need to define a few parameters. So we have to tell also the system where we have our input data is this sample data. So I just say sample data absolute, it will, so here I say it's sample data because this notebook is located in the same folder as sample data. It knows. So then if I say absolute, I get this full path. And also I want to have outputs here on this folder called outputs. And then I get for the Modis Aqua exercise, I use this Nomad chlorophyll and fluorescence. Here, the file that you receive, the file that you submit to the system is simply like this. And the one that you will get back will have matchup appended. So meaning that this data already contain the matchup. And then for the SGLI, this one. So we run it, and then we get the information. And then we scroll down. Here, for reading, we will be using pandas. These files, I forgot to mention, the files that we submit to the system should be a CSV file. So I will open the CSV file so you can see the structure inside. You can use any text editor to open it. So this is how it looks. You have the header information on top that says what each column contains. The first is cruise here for this case, and then we have year, month, day, hour, minute, second. And then we have the latitude and longitude, and we have ID, and then other information, bathymetry and chlorophyll. So this is a comma separated file that we submit, and what we get back, which is this one, containing the metadata. It will have a header. This header explains what kind of matchup you run. You selected Modis Aqua, and then what time you submitted your request, and who submitted, and the email address, and then it will tell you about the missing value, what you should call missing value, and then the limiter is comma here, as we can see, and then your validation criteria that you selected. You selected a box size of 5 by 5, and you selected a minimum percent for valid satellite pixels of 25. Then you also selected time difference between satellite and in situ of 3 hours. And this is a combination of the flags that we turn on. So we turn on atmospheric failure, land, cloud, chlorophyll failure, and navigation failure. And from once this header ends, then start the same structure of the data we had before, but this time it includes other data. Previously, it stopped on chlorophyll. So now it continues, it has date time, means just a combination of date and time. It has a file name, where the matchup was performed. It tells you which variable was this. Here we have chlorophyll A and other like RRS. It has the start time of that file, the end time. It contains valid pixels, invalid pixels, and the minimum among the 25, maximum, mean, standard deviation, median, and the value of the point of your long light point. And then it gives you also the pixel value. Here we have 25, means that you have pixel values for the 25 pixels from 1 until 25. And after that, after the 25 pixels are done, then you get the flags that existed in that pixel. For each pixel, it will tell you what kind of flags were originally exist, not the flags you applied. This is just the flags that exist in the original data. Whether you apply it or not, these are just means, for example, here you see that we have 1, 1, 1, but sometimes you can have 2 or more. In this case, for example, we have this mode cleaned and product failure. So you can have 1 or more flags, depending on the kind of flags that exist in the pixel. Okay. So using pandas, so if you pay attention to this file, you can see pandas can read easily this kind of file because it's a structured file. So this header information or metadata has 14 lines, 14 rows. So we can skip, we can tell pandas to skip these meta rows and read from here. It automatically knows that the first one should be metadata, I mean header of the table, and the remaining is our data. And the good thing about using pandas is that we don't need to worry about whether we have numbers or characters. Like this one, we have mixed things. So we can simply use here pandas. Pandas, we gave it alias. We said import here, import pandas as PD. You can learn more about use of pandas by going to the pandas website and checking this read CSV command. And then we say PD read CSV. We have our aqua file, which we defined here. We already defined the file, and we tell it skip 14 as we have it inside our information. Header rows are 14, so we want to skip them. They are not important for us. So then we press read, and then we ask Panda to tell us what kind of information is contained inside this file. We say .info. So when I say .info, it will tell me on 0, the first column is cruise. It has this number of rows which are not non-null, means non-empty, and it automatically detects that this is object because it's character, and here it's integer. So all these things, and then for the case of chlorophyll A, it says it's a float, and then we have all this down to about 74. So all information is contained here. You can also, instead of saying info, you can say head. Then if you say head, you just see the header information, which will show you in terms of table. So this time you see it as a table. So you will have this cruise here, information will go down this way, year this way, and so on. And then it can move until the end of the table. So here you can see that it shows you as a table. Okay. Okay. And so also we want to extract some information from here, because the table doesn't show everything. So sometimes we just prefer to say info, because we will see these are the header information. So we can know what we want to extract from here. So we are interested in one column is chlorophyll, which is the in situ. From here we can see is this one, 11. And another one is median value. So the median value from our mashup, which is here on 23, we can select. I mean, you can select any of this, anything from this table can be chosen for analysis. But here we just want to use median. And then remember that I explained that this each variable is inside here. So in here we have chlorophyll. On our rows, we have chlorophyll RRS. So we have to be able to extract only chlorophyll. So I will use this one to select rows that are specific for chlorophyll. So this is what I call var field, and select is just selecting var is chlorophyll. So here, if I put this data frame here, which I just read our data frame here, is aqua DF. If you put this one on square brackets, you can see what is inside on this specific column. And on this specific column, we have chlorophyll, RRS, and other parameters. And then there is some explanation. We don't need to spend so much time on how to do it, but you can see it. We can select. Is in tells you that you want to search chlorophyll that is in the variables. So this will be indexed. It will be true where you have chlorophyll and false where it's not chlorophyll. And if you apply this index using location, log means location for your data. So you find the location where it's true for chlorophyll and it will extract. And then true for medium, it will extract. So we call it this X and Y. And then we get the data here. You can see this is the chlorophyll and tells you the length of the data. And then for medium also, it tells you the length of the data. So you get this time series. And then here we use matplotlib to display the data. So here we are using scatter plot. We have our X and Y, and we say color is black and marker and other parameters. This is just a scatter plot. And then we set the X-axis is in situ chlorophyll and Y-axis is satellite-derived chlorophyll. And we set it to log scale, and then we display it. So if we run, let's run from here. We run this cell. We also run this one. We run this one. And we run this one. We should be able to generate a plot like this one. So this is the plot. There are other additional things that are just added, I mean, just optional. You don't have to, I mean, they are not so important for now. But here, you have these points on the X-axis, you have in situ chlorophyll. On the Y-axis, you have satellite-derived chlorophyll. And this red line is one-to-one line. And here, I added a few additional lines. This is half. So you can see the legend here is saying X equal Y, and green is a linear regression line for this data set. And blue dots are very low, I mean, the satellite underestimate in situ data. So this one are much lower than 1/3 of the data. And red means overestimation, is over 1/3, 3/1 of this satellite data. So you can get this, and you additionally it give you a few statistics parameters like R-square and correlation coefficient and p-value. Okay, so yeah, you can try to run it and okay. Oh, yes. Yeah. Most probably, some people also are facing this pandas. I think we forgot to add pandas to the module that we have to install. If you are having this issue of module import error, just do the same thing as we did previously, pip install pandas, and then the issue will be resolved. So yeah, this is the exercise. So please try to run it until here and see the result you get. If you have any issue, please let me know. You can also run one by one until here, so that you follow the you try to understand the flow of the exercise, and you can do it in 10 minutes. So we will do it until 9:10, and then from there we can take a short break. So start by importing all libraries here in one. You will import pandas, numpy, and datetime, and then also import the system and path. Those are used to handle our files. So we want to be able to deal with input and output easily. And then we also import matplotlib. Matplotlib we use for visualization. Then we import those, and we also import our custom tools, modules that we prepare. Then here, different from level 2 flags, we are not using dataset. We are not using netcdf, but we are using a text file. So this text file is located here, also in the sample data, but now we read this text file with pandas. I believe by this time I received my mashup. So you can see I also receive additional because I manage this system. I get also information about other people. So mine is this one, and it's telling me that I ran this, and I should get information about here. It says it's completed, and I can download. You see, I can download my mashup from this link. If I click it, it will download the mashup for me. So here. So I can save it here, and yes, so now I have, this is the file that I recently ran. So I could get a few matchups. If I open with text editor, so looks like only one file could get a mashup, others didn't. But yeah, we see that we could successfully run the mashup. So can anyone run it without any issue? So if you have any problem, please post it in the chat. Yes, I get a question that whether we can change the box size. Yes, we can change the box size. Of course, default we put 5, but yeah, you can change it. You can be, actually you can have just the pixel value only, or you can put it 3, 5, but please use odd numbers, not even numbers. You can have it 1, 3, 5, 7, or 11. I think it goes up to 11. Yeah. You can also use this to change. You will see that it doesn't accept to move over 11. So yeah, I think that was max. And then you can change it this way. Yeah. Yeah, so anyone interested in playing with this can also select different RRS bands and try to compare those band combination with city chlorophyll. The procedure is same, just instead of chlorophyll, you can select each RRS band here, and then you will get the value of the RRS. So here I selected chlorophyll A, but you can also have, let's say, RRS, just copy as it is here and replace it here. When you replace it here, then the selected value when you come here, the selected value now, instead of being chlorophyll, this would be a medium of RRS. Of course, here, because we are picking the medium, the line of medium value, but this is the medium value of chlorophyll, of RRS. So you can also see the values themselves. You see that these are much lower values compared to previously chlorophyll values. So this is the range of RRS values. So it means now it's picking RRS. So you can select different bands of RRS and play with it and get any kind of analysis you might be interested in doing. So can everyone run the exercise without issues? About one note about these identity lines. So these identity lines, you can change them from this part here. So you can see here, I have identity line, I have 1, 2, and 3. So this one will add 1 to 1, 1, 2, and 2, 1, and 1, 3, and 3, 1. So you can limit it to this 2 or to 3, I mean, yeah, depending on whatever you want to do it. You can change and just adjust it the way you like. And the name of the labels, you can change it from here. Here we set the scale to log. If you don't set the scale to log, the default is linear. And this is the y-axis limit, minimum, maximum. So we keep equal to both axes on log scale. Okay, so it's now 4:10 p.m. in Japan. We will take a short break of 10 minutes and we will resume 4:20.